Polynomial is an algebraic expression of many terms made up of coefficients, variables, and exponents. The exponents must be positive integers. So a monomial has one term, a binomial has how many terms? 2 terms. And the terms will be separated with a plus or a minus. So it might be like 5x squared plus 3x. Notice that they're not like terms, because if they were like terms, we would combine them into one. And then the trinomial is going to be, of course, 3 terms. So it might be like 5x squared plus 3x plus 8. Now notice 8 doesn't have a variable on it. You can have a constant term. A constant term is a term that doesn't have a variable. All right, any questions so far? All right, so then we have 2-factor and then we have a-factor. 2-factor is what we're going to be doing in this lesson. We're going to be undoing multiplication. So you guys know how to like multiply by distributing, right? If you want to undo that distributing and split it into 2 factors, that's called factoring. That's what we're doing, just to undo multiplication. When you undo multiplication, you end up with 2 or more factors. And those are polynomials that multiply to at least one more polynomial. So if you look behind Ella and Kelsey, there was a multiplication problem similar to what we did in the last lesson. Here's a multiplication problem, and you end up with this polynomial down here. I don't see that many eyes yet. So this is a polynomial. If I'm working backwards and I'm undoing the multiplication, I would end up with these 2 factors. The process of breaking it up is called factoring. And these are the 2 factors that I get. Those are the polynomials that are multiplying by other polynomials. All right. Standard form. In order to factor, you need your polynomial to be in standard form, and you did have that in your last delta math, where the terms have to be arranged from the smallest exponent, from the largest exponent to the smallest. So the biggest one goes first, and then the smallest one is often the constant term because it doesn't have an x at all. I apologize, it's a lot of writing, but we're going to get to some problems in just a minute. Okay. And I think this is the last one. The constant term is the term with no variable. Now you don't always have a constant term, but often you do. So if you have a term with no variable, that's the constant term. So when we're talking about factoring, we might be using some of these vocabulary words. It's important to understand what they are. All right. So at the beginning here, we have some problems that are probably review. And the reason why we have these review problems is because before we can work backwards, we need to remember like how it worked forwards. So we need to remember things like when I multiply 3x times x, I have to add the exponents, and if I don't see an exponent, I'm going to give it an exponent like that. So 3x times x is going to give me 3x to the what? I heard one vote. Anybody else? To the 2? That's right. Plus, and then 3x times 4 is going to give me 12x. Okay, take a minute to do example 2. Check with your neighbor, see if they get the same thing as you. All right, so when you multiplied, I know you multiplied the 4 times the 2 to get the 8, but what do we do with the exponents when we multiply? You add them, yeah. So we get 8x to the what? To the 3, good. And then minus 4x times 1 is just 4x. So check and make sure you have 8x to the 3 minus 4x. All right, down here for multiplying, I'm going to do one example with a box method and one with FOIL, which is really just distributing. And then you can use whichever method you want for these two. So first one, with the box method, you're going to draw your 4x4 box. And I put the 3x and the 2 on one side, and then the x and the minus 1 on the other side. And then I multiply the 3x times the x to get 3x squared, the 2 times the x to get 2x, negative 1 times 3x to get negative 3x, and then negative 1 times 2 to get negative 2. Do you guys see the like terms in there? It's kind of tiny. Yeah. So the 2x is a like term with what? The negative 3x, yeah. So those two are my like terms. So I'm going to keep the 3x squared there. 3x squared. Combine negative 3x and positive 2x to make a negative 1x, or just negative x. I'm going to write negative 1x for those who are still trying to figure that out, but you can write negative x, that's even simpler. And then the minus 2. So multiplying with a box is one method. The other method is distributing. I'm going to pause for a minute for people who are still processing this one, and then we're going to distribute, and then you're going to work on 5 and 6. Okay, let's distribute. So for this one, remember if I have x, that's the same as 1x. And if I don't have an exponent, I can give it a 1 so that when I distribute, I know what to multiply and what to add. 1 times 5 is 5. X to the 1 and x to the 1, that adds up to 2. X to the 2. So I get 5x to the 2. 1x times 2 is 2x. Then negative 4 times 5x is negative 20x, and negative 4 times 2 is negative 8. So that's exactly what you would get with a box. It's just a different method. It's distributing. You can decide which method you like. I still have like terms to combine. 5x squared, what does that give me? Thank you, Osman. Negative 18x and then minus 8. All right, go ahead and do 5 and 6. Did anything interesting happen with number 5? No, nothing interesting? X times x gave me x squared. X times minus 2 is a minus 2x. Then I have a plus 2x. And then I have a minus 4. So what happened with my middle term? It did, thank you. So the negative 2x and the positive 2x cancel to make nothing. They cancel out. So you just get x squared minus 4. All right, does anybody think they can explain why I said x squared minus 9 is wrong for number 6? Go ahead, Ryan, what do you think? It's squaring the whole binomial, true. So to square something, you multiply it by what? If I want to square 5, I multiply it by what? 5, good. If I want to square 10, I multiply 10 by 10. So if I want to square x minus 3, I have to multiply x minus 3 by what? X minus 3. Okay? So if you haven't written that out yet, do it now. X minus 3 times x minus 3, and let's see what we get. Okay, hopefully I'm a step behind you. So I have x squared, and you're right that there will be a plus 9, but I'm not there yet because I got a minus 3x and another minus 3x And then Yusuf is right. There is a plus 9 here.
Start cheesing.
All right.
Cracked cheese.
Are there any like terms?
Yes.
Yes, like terms. Do they cancel out? No, right? Because they're both negative. So negative 3x and negative 3x will give me what? Negative 6x. Good. All right. All right, so don't be fooled when they ask you to square a binomial. People are always tricked into thinking it would be x squared minus 9, but not you. You know to multiply it out. Okay, when you're ready, turn the page.
I gave it to Jake, and then I was like gonna be on. Oh, I bet it's a joke.
Something like a long time ago. So Kanye West is watch Kanye West about
All right, guys, you've gotten a little chatty, and I need to redirect you back to this because this is where things get new. Factor, right? Remember that factor means to undo the multiplication. So now we're ending with the answer. So here's an answer. It's almost the same, kind of the same, but there's something a little bit different about it. So we're going to start with the answer, and we have to end up with the two factors that would multiply to give us this. Here's how we do it. We need to find the greatest common factor of 3 and 12. What's the biggest number you can divide 3 and 12 both by?
4. 3.
All right, so if you're not sure, try it, guys. On your calculator, do 3 divided by 3, do 3 divided by 4. Which one will give you an integer answer?
3.
3, good. So the greatest common factor is 3. And you're going to divide both terms by 3, like that. Go ahead and do that. The number that you factor out goes on the outside. The number that you factor out goes on the outside. Then, here, 3x divided by 3, the 3's will cancel and I get just x, plus 12 divided by 3 gets me the 4. In the second one, you will have a greatest common factor that's a number, but notice that they both also have x. So in addition to factoring out a number, you're going to be able to factor out x. Take a minute and see if you can figure out the greatest common factor number, and then also divide by x. All right, guys, get this one down as your example. And then take this one. The biggest number you can divide by 12 All right, guys. What's the biggest number we can divide 12 and 16 by? Right on your calculator. So type 8.
I like a burger.
Remember like sharp.
You like a
You know some weird, bro?
Okay. What is the biggest number that you can divide 12 and 16 by? 4. They both have x, so we're going to divide them by 4x, like that. So, 4x goes on the outside. 12 divided by 4 is 3. What is x squared divided by x? All right, that's right, but why is that right? X squared divided by x is x. So, okay, so Osman's remembering that you could subtract the exponents, so you could definitely do that. 2 minus 1 is 1, that gets you 1. So that's one thing you could do. Another thing you could do is remember that x squared means x times x. So then you can write x squared out as x times x and cancel these out, and then you get just x. Either way, though, you need to know x squared divided by x is x. Over here, these will cancel, and you have a minus 4. All right, does anybody have a question on that one? Number 9, you have 3 terms. You need to take a greatest common factor out of all 3. Do that, please. Greatest common factor. All right, you have a nice graphic here. It doesn't really mean a lot to us yet. This graphic doesn't mean a lot to us yet because we haven't learned a whole lot of different types of factoring. So far we've learned to take out the greatest common factor. That's what we've been doing. These are some other types of factoring, and we are going to learn difference of squares now. So difference of squares is when both of the terms are perfect squares. I can see that x squared is a squared because it has a squared on it, right? 25 is a square because it is what number squared? What number squared gives you 25? 5 squared is 25, right? So you can rewrite this as x squared minus 5 squared. Because 25 is 5 squared. When you write it this way, then you're going to write it as a product of 2 things with a plus and a minus. Always with a plus and a minus if you have difference of squares. I'm writing that as a separate step because it's the first time we've written it, and I want you to see what happens there. To get the x squared, it has to be x times what? X times what gets you x squared? I heard one answer. Anybody back there also have an answer? X times what gets you x squared? X times x. X times x is x squared. Okay? To get 5 squared, it's 5 times 5. Now, what we just did was we found the 2 factors we could multiply to get this, x squared minus 25. Notice it's a minus 25, and that's why we need a plus 5 and a minus 5. If I multiplied these out by distributing, I should get 4 different terms, right? X squared, 5x, negative 5x, negative 25. How come this only has 2 terms? What happened to my middle terms? They canceled out, yeah. So if I were to multiply this out, I would get x squared, negative 5x, positive 5x, and negative 25. My middle terms cancel out. So this is why you can factor the difference of squares. I'm going to do the first step for the next one, and then I'm going to have you guys write the answer. We need to write this as 2 different things squared. I already know that 25 is 5 squared. 9x squared is what squared? Okay, I heard 2 different answers of 3 and then also x, right? 3x. So if I square the 3, I get 9. If I square the x, I get x squared. Now you're going to use those 2 terms in your plus minus pattern. So take a moment and fill it in. Okay? Follow the pattern. Difference of squares always has a plus minus pattern. You need to do an extra step there, okay? Yeah, so Ryan points out that when you're multiplying 2 things, it doesn't really matter if the minus comes first or the plus comes first, okay? If you want to do a minus plus pattern instead of a plus minus pattern, no big deal. Good start.
So funny.
Everyone just said, multiplying numbers and numbers.
Oh my gosh.
None of you guys have heard about that.
So nice, bro. We should get this brother to talk.
The gaslighting is not working. Everything we're on it.
Can we tell bro here's about the peninsula?
Yeah, wait, Barry's like,
Alright, do you guys have a question?
yes.
Yeah, honestly, yeah, that.
So, in this problem, in this problem, at the x squared with the x here,
If you're dragging the
but
urethra.
instead of x, it's minus what?
3x. So 3x right here.
Yeah, and
She said,
Okay.
Wait, can you walk?
Alright guys, so notice in the last one to get the x squared it was x times x. This time we have the square of 3x, so it's going to be 3x times 3x, right? The 5 squared is the same thing, so it's going to be a plus 5 and a minus 5. Alright, so 3x times 3x gets us the 9x squared. Then we have a minus 15x and a plus 15x that cancel out. And then you have a minus 25. So we undid the multiplication and we factored. Okay. Notice 12 and 13 are two-step problems. I'm going to do 12 and then you guys are going to do 13. In 12, they don't both have numbers, but I can factor out what variable? X, yeah. I'm going to factor out the x. That comes on the outside, and then I have x squared minus 81. So it says greatest common factor and then difference of squares. 81 is the square of what number?
9.
It is 9. So it's going to be x times x squared minus 9 squared. So notice the x stays on the outside and I have a plus minus pattern. To get the x squared, it's going to be x times x. And then this is going to be 9 times 9. Alright, you guys are going to do number 13. Start by taking out a greatest common factor and then do difference of squares. Factor that we took out. It was 12, right? So you divided both of these by 12. And the 12 comes to the outside and you had x squared minus 9. And then 9 is the square of what number? 3, good. So the 12 stays on the outside. You have x squared minus 3 squared. And then you do your plus minus. Guys, what do we put for the x squared? What times what? X times x, good. And then for the 3 squared, we have 3 times 3. Remember that in the end, you need to put your 12 back out front, okay? So make sure you have that, because there's one more kind of factoring we're going to go over. We're going to start the next set of notes, and we'll see how far we get.
Punching bag when she walked. Punching bag when she walked.
All right, may I turn the page? No, some people are still writing. All right, so factoring trinomials with a equals 1. Here's the reason why it says a equals 1. A trinomial is in the form ax squared plus bx plus c. So when a equals 1, then you just have x squared plus bx plus c. So we can only do this method if you have x squared and not like 2x squared or 3x squared. It says the a must be 1, so 1x squared to start. So you first look for a GCF. So let's see if we have a GCF. Is there a number that we can divide all 3 terms by? No, because there's no number. Do they all have x? No. So there's no GCF. So now we do this number game. You might remember this from Algebra 1. The factors of the constant term. So what multiplies to the constant term? Which one is constant term?
12.
Yeah, the one with no x, right? Which is what?
12.
12. So what multiplies to 12 and then adds up to the coefficient of the middle term? adds to 7. Now, some of you are super good at this, and that those numbers just pop in your head, and don't ruin that for everybody else. All right, if they pop in your head, just write them right here, okay? Now, if you have trouble with this, here's what I do. I make a list of numbers that multiply to 12. So 12 could be 1 times 12, 2 times 6, or 3 times 4. And then I look at my list of numbers, and I say, okay, now which of those adds up to 7?
4, 3.
That says 4 and 3, is he right? Yeah. 4 and 3. What if you said 3 and 4? Would you still be right? Yes. All right. Then it says to write the factors. Now, to get x squared, it's just going to be x times what? X squared is x times x, thank you. And then to get to 12, we know it could have been any of these things, but we needed the pair of numbers that adds to 7. So that's going to be the 4 and the 3. Since the 4 and the 3 are both positive, we're going to put a plus. Now you can check every single factoring answer by multiplying it out to see if it gets you back to this. So when you take a quiz on this, you could get 100 because you can check every answer by multiplying it back out. But we're not going to do that right now. All right, next one, factor out the GCF. 3x squared minus 6x minus 45. Is there a greatest common factor? It is 3, right? Okay, so we're going to factor out the 3, and that's going to leave us with x squared minus 2x minus 15. Now, this is the reason why I can do this method, because remember, I could only do it if it's 1x squared. I factored the 3 out, so now I can do my method with 1x squared. Okay, so I need factors that multiply to what number?
9 and 3.
I don't want the answer. That multiply to
9
what?
and 5.
Multiply to which of these numbers, guys? Negative 15. This one, the constant term. And then add to what number? Yes, add to negative 2. All right, so I'm going to put those numbers here when I find them. I'm going to make a list. And when it's negative, it's a tricky because it could be negative 1 and 15, or it could be 1 and negative 15. Make my little list over here. So it could be negative 1 and 15, or 1 and negative 15. It could be negative 3 and 5, or it could be 3 and negative 5. You can use your calculator to add those and see which ones add to negative 2. If you think you have them, check with your neighbor, see if they agree.
Agreed.
All right, I can already tell it's not going to be these two. Did anybody figure out yet? Is it negative 3 and 5 or 3 and negative 5? So if you're not sure, let's check that answer. 3 and negative 5. At 3 plus negative 5, does it give you negative 2? It does. Okay, so when I write the factors, I'm going to bring down this one on the outside. To get the x squared, it's always going to be x times x. Oops, I wrote negative 15. Why did you guys stop me there? 3 and negative 5. So the 3 is a positive 3. That goes here. And then this is a negative 5. That goes here. All right, who has a question? All right. Yes, go ahead.
What if when you're doing the GCF part,
Uh-huh.
stuff, what if you can't divide, like, what if it's like, instead of this negative 6x, it's
Uh-huh.
just negative 5x?
Okay, you guys, Ahmed asked an excellent question. I'm going to give you an example of a problem that he's talking about, and this is not something that I've taught you today, so that's going to happen next class, okay? But he's saying, what if it was like 3x squared minus 5x minus 45, right? There's no GCF, and there's a number in front of the x squared. This is a harder kind of factoring. We're going to learn this next class, okay? So in this case, you should be able to factor out a GCF today for any problems that have a number in front of your x squared. Please try 1 and 2. We're going to go over those very soon. Problems. Okay, this one, we need two numbers that multiply to negative 20, because you see the negative 20 there. What do they have to add to? Nahar says negative 1. Anybody agree they have to add to negative 1? There's no number here, but there's a minus sign. You can put a 1, and so he's right. They have to add to negative 1. All right, so for negative 20, I'm going to start making a list of numbers. It's a long list. Negative 1 times 20, 1 times negative 20. Negative 2 times 10, 2 times negative 10. Negative 4 times 5, and 4 times negative 5. Now, you don't have to write that list down if you know it more quickly, but if it helps you, write out your whole list. What numbers add to negative 1? Yeah, negative 5 and 4. These are the numbers. So I'm going to write my factors with parentheses. X squared is x times x plus 4 and minus 5. All right, and then in number 2, we had a greatest common factor. What was it? 2. So we're going to factor out the 2. And that leaves me with x squared minus 10x plus 16. Put the 2 out here. And so now I need two numbers that multiply. Let's separate these. Multiply to 16 and add to negative 10. How is that possible? How can two numbers multiply to positive 16 and add to negative 10? All right, Shahir says 2 negatives. Would that work? Does negative times negative give you a positive? And negative plus negative, does that still make negative? Yeah, okay. So we need two numbers that are negative that multiply to 16. So it could be negative 1 and negative 16, negative 2 and negative 8, or negative 4 and negative 4. Which pair of numbers adds to negative 10? The 2, yeah, the negative 2 and the negative 8. So this 2 on the outside, it's going to come down. To get the x squared, it's still x times x. And then to get the 16, it's negative 2 times negative 8.